Assalamualaikum warahmatullahi wabarakatuh. My name is Rafiq bin Alias. Our group will be present the Stoke Theorem. My group consists of 5 group members: Amirul Azham bin Mahali, Muhammad Arif Ashraf bin Maidin, Muhammad Faiz bin Hamzan, Muhammad Rashidi bin Razali, and me myself, Rafiq Hilmi bin Alias. Introduction of Stoke Theorem. Stoke Theorem, also known as Kelvin-Stoke Theorem, is the fundamental theorem for curls, or simply the curl theorem. The theorem relates to the integral of curl of the vector field over some surface, to the line integral of vector field around the boundary of the surface. Next is the theorem. Let B sigma be a smooth oriented surface in R3 with boundary of lower sigma if a vector field A is equal to P xyz, Q xyz, R xyz is defined and has continuous first order partial derivation in region containing sigma. Then the equation that we will get more explicitly, the equality say that the formula derivation in 1 will be the main challenge in the precise statement of Stoke theorem is defining of the notation of boundary.
My name is Faiz, and now I will show some one of example of Stoke theorem. Given the equation, if is f x y z equal to y z I plus 8 x z j plus e exponent x y k, with the c is equal to x square plus y square equal to 16, and z in the plane z equal to 8. So the first thing we need to do is z substitute z in the equation, and then by using Stoke theorem we will get this f integrate f dr equal to 8zi plus 64yj plus exponent xyk multiply with Stoke theorem dr. And then when we rearrange, we will become this. So now we use x equal to 4 cos theta and y equal to 4 sin theta. Then we differentiate x and y into respect with the theta. Then we substitute x, y, dx, dy, and dz into equation 1. So since the area of the circle is full rotation, which is from 0 to 2 pi full rotation, so we can differentiate it from limit 0 to 2 pi. Then we can bring out the numerator to the outside, and it became equation 2. We know that in trigonometric identities there's a equation where sin square theta equal to 1 minus cos 2 theta over 2, and another one is cos square theta equal to 1 plus cos 2 theta over 2. Then again we substitute these two equations in equation number 2 just now.
Assalamualaikum, I am Muhammad Rashidi and I will explain about triple integral in spherical coordinates. So, The following sketch or graph show the spherical coordinate system for triple integrals. So, what we have in triple integral in spherical coordinates? The first, the system separates into three axes, which is x, y, and z. The angle made by the radius and the vertical axis is denoted by phi. So, from the graph, a point P has been represented. So, what are rho, phi, and theta? Rho is the distance from point P to the origin. Phi is the angle between positive z-axis and the line from the origin to the point P. And theta is the angle from cylindrical coordinates. Rectangular coordinate x, y, z are transformed into cylindrical coordinates by equation x, y, z, radius, and rho squared. The restriction on the coordinates are rho greater than 0 and phi less than 0 and greater than pi. Suppose that this is continuous on spherical box-shaped region G of the form of G, and then we have triple integral equation. Also, we have here volume elements and coordinate conversion formulas.
Assalamualaikum. My name is Muhammad Arif Ashraf bin Maidin. I will be explaining about how to do triple integral. Let's look at the question. The question asks to evaluate the integral 0 to 1, 0 to x, 0 to 1 plus x plus y, fx, yz, dz, dy, dx, where fx, yz equals to 1. The first step that we need to do is integrating the equation with respect to z. Integrating 1 with respect to z will be z, with limit from 0 to 1 plus x plus y. After substituting the value of limit, the answer will be 0 to 1, 0 to x, 1 plus x plus y, dy dx. The next step is integrating the equation with respect to y, with limit from 0 to x. By substituting the value of limit, new equation will be achieved, which is 0 to 1, x plus x squared plus x squared over 2 dx. And the final step is integrating the equation with respect to x, with limit from 0 to 1. And the final answer will be equal to 1. This is the simplest example on how to do triple integral step by step.
For this part, we will discuss about the sample question of triple integral for spherical coordinates. The question is, find the volume of the solid bounded above by sphere rho equal to 3 and below by cone phi equal to pi over 3. For the solution, first we write the formula of volume for triple integral, which is v equal to triple integral 1 dv. And then for the next step, we find the limit for the triple integral. For rho limit is from 0 until 3, since the rho is equal to 3. And for phi limit, from 0 until pi over 3, since the phi is equal to pi over 3. And then for the theta limit is from 0 until 2 pi, since this is sphere. And then we just solve the triple integral. First, we integrate the rho square, and then we will get 1 over 3 rho cube. And then we just substitute the limit 0 until 3. And then we will get 1 over 3. We move out the 1 over 3, and then we solve the 3 cube minus 0, and we will get 27. And then for the next step, we integrate the phi, which is the sine phi, which is we will get negative cos phi, and then we substitute the limit, which is 0 until pi over 3. And then we will get negative cos pi over 3 minus negative cos 0. Then we will get 9 multiply y over 2 integrate d theta, and then we integrate the d theta, we will get 2 pi, and then we just multiply the 9 over 2 multiply 2 pi, and the value we will get is 9 pi. That is the answer.